Hello everyone. In the previous video, we have solved a few questions of Cauchy's integral test. In this video, we will be solving a few questions of Cauchy's root test. So, the first question I would take up as, so the test the convergency of the series whose general term is this. Now, you have to remember what was the Cauchy's root test's proof and statement. So I told you guys when I was showing you the proof of this Cauchy's root test, I told you at that time that this proof is unique in its own because it deals with the power. Like this is the only series whose elements of the series contains power. So it will be easy for us to identify in exam also that what type of question is this. Like I've given you the question which contains power. All right, so you can easily figure it out that yeah, it will be solved by Cauchy's root test. Okay, so what is its statements? Let series un be infinite series of positive terms, and let this un to the power 1 upon n is equal to L. Now this L will converges when L is less than 1 and diverges when L is greater than 1, and it will fail when L is equal to 1. So this is just the opposite of each and every ratio test and all those tests. We have used to have L greater than 1 for the convergent. Okay, so in this we have less than 1, greater than 1, then it will be divergent. So what is first approach? The first approach is to simplify this. Okay, so un term is actually n to the power n square upon n plus 1 n square. So I in the RHS side I am writing it as a un. Okay, but what do I want? I want un to the power 1 upon n. Okay, so I am taking common here n to the power n square. Okay, so I will left with 1 upon n to the power n square, and this will get cancelled. Now I will write it as 1 plus 1 upon n whole to the power n square. I can write it like this. Now I want 1 upon n this side. If I shift one power of n to that side, so it will become 1 to the power n, and it will left with 1 upon 1 plus 1 upon n whole to the power n. Okay, now I'm gonna take the limit n tends to infinity both the sides. Now if I put the limit here, it will be in the form this will become 0, and this is infinity, so it is actually in the form of 1 to the power infinity. I told you guys about how you will do the approach, how you gonna do the process of solving 1 to the power infinity form. I hope you guys remembered that steps. E to the power limit n tends to infinity 1 plus 1 upon n minus n. So 1 minus 1. Okay, and this is limit n tends to infinity, and n will get cancelled, so you will left with 1, so it's actually e. Okay, this is your rough work. Okay, so this is actually for this term 1 plus 1 to the power n whole infinity. Yes, so the whole answer will be 1 upon e. Are you agreeing with me? Now this 1 upon e, actually what is the value of e? We know that e lies between 2 to 3. Okay, so actually when your denominator is greater than numerator, the answer is less than 1. Okay, so it's actually less than 1. This 1 upon e is less than 1. So from the Cauchy's root test, I can say that this series is convergent. All right, hence it is convergent. Okay, let's take another question quick. You have to find out the un term, the last term, what will be the nth term. So you have to see the pattern that this is 1. Let's 1 is equal to n. So this will be n plus 1. Okay. 1, 2, 3. The denominator is actually going to nth term. Okay. And the numerator is started from the one term successor of 1. So it is actually n plus 1, n plus 1 square upon n. This is square, right? This is also square. So I can simply write it like this, or in terms of, I can write in terms of n plus 1. I can simply write n plus 1. I've written in terms of n plus 1. Why? Because we actually want un to the power 1 upon n. So for that, I just need to add n in the power. Okay, minus n plus 1 upon n. And if you notice here, one thing is missing, that the entire power is minus 1, minus 2, minus 3. Okay, so simply the entire power will be minus n. So this is the nth term. Just remember that you have to add n in the power in any form. Okay, I have n in the power. Okay, now what's going to do now? I will be taking n as common from this side. So you can simply do, no, before taking common, I'm just dividing n upon n. 1 plus 1 upon n to the power n plus 1 minus this side also 1 plus 1 upon n minus n. All right, now what's the approach? Putting there is actually minus n over this side, and if I shift this minus n to LHS, I will left with un to the power 1 upon n is equal to 1 plus 1 upon n to the power n plus 1 minus 1 plus 1 upon n minus 1. You guys know that if I put the infinity to this side, infinity, here also limit n tends to infinity. Actually, this is minus 1. So if I write it properly, this will be in the denominator part. Okay, so I'm writing in the back page. And when I put the limit n is equal to infinity, this will become 1 to the power infinity form. Okay, so this will become 0 and this will become 1. So this is e. So entire thing I will sum up as e minus 1. Okay, now as you know that e lies between 2 to 3. Okay, so this is greater than 1. So if we subtract 1 from the value of e, still our answer is above 1. Okay, because let's take the e as a 2.5. Okay, let's for example not 2.5, something 2.2 or something like that. If you subtract 1, you will still get some value which is above 1. Yeah, so 1 upon something which is greater than 1 will give you result as less than 1. Are you getting my point or not? Something which is greater than 1, if it's in the denominator, that will give you a result less than 1. So it's actually less than 1, so this is also a convergent. Okay, so hence by Cauchy's root test, the given series is convergent. All right, hence it is convergent. Let's take up another question. So this is a very simple question. You can solve it on your own. First, un is equal to, because the un term is already given, so you have to term this series as a un. In second step, go and shift this n to the LHS side, 1 upon n. Still you have 1 n left over here, and this is again the form of 1 to the power infinity. But remember one thing, that you have now minus sign over here. So if you solve that e part, you will get e to the power minus 1 actually. Okay, you solve it. Okay, so e to the power minus 1. How? Let me show you here. e to the power limit n tends to infinity. Okay, first n, and then it's going to be 1 minus 1 to the power n minus 1. So you still left, if n and n getting cancelled, but you still have minus 1 over there. So e to the power minus 1 is 1 by e. So again it is a less than 1. Okay, so it is less, if it is less than 1, then it's going to be the convergent. Okay, so series converges. Series, okay, whatever the spelling is, it's convergent. Hence, it is convergent. Okay, let's take another question. Here's the another question. Now I have log, and if I'm dealing with the log, then I have to take limit from 2 to infinity, because the moment I will put the value of n as 1, this will become 0, and that will be meaningless. So I have to set my limit from 2 to infinity. So uh, un is equal to 1 upon log n to the power n. Now shift that side, I have this 1 upon log n, and if I put the limit as infinity, okay, limit n tends to infinity, un to the power 1 upon n is equal to limit n tends to infinity. Now you guys know that limit n tends to infinity, log n gives you infinity, but it is in denominator, so it will become 0, and this 0 is less than 1, so it is convergent. It was so easy. Now the question I'm taking, it's an important question. 1 upon n. Now this is a very important question. Okay, how? Let's see. First, un is equal to 1 upon n, 1 like this. Now if I shift 1 upon n to LHS side, un to the power, it will become un to the power n, not 1 upon n. I'm sorry. Yeah, so it will become un to the power n, not 1 upon n. So I have to do 1 upon n like this. I have to put 1 upon n into 1 upon n. This will become 1 upon n square. Okay, so 1 upon n to the power 1 upon n square, un to the power 1 upon n. Now if I put the limit as infinity, this power will become 1 upon n square. This will, if I put infinity here, this will become 0, and something, if it is having power 0, it will result you as 1. Are you getting my point or not? Say this very easy concept. This will become 1. Are you getting why? Because this entire thing will make end up having 0. So 1 upon n to the power 0 is 1. It's a simple algebraic rule in the lower classes we have studied. So it will giving me 1, and we know that Cauchy's root test fails when its value becomes 1. So what's going to do now? So you can apply the another test. Did I tell you earlier which test you have to apply when Cauchy's root test fails? No, because you can apply any test, but any test, no, you can apply comparison test. Comparison test you can apply simply. What you have to do here? Or you can apply p-test as well. So actually this is 1 to the power n to the power 1 upon n. N square. So if you consider this as p, 1 upon n to the power p, now this p has to be, now if you now this p, if it is equal to 1 or less than 1, then greater than, yeah, sorry, let me fix in my mind. Yeah, so if this p is less than or equal to 1, then this will be diverging, and if it is greater than 1, then this will be converging, right? So this is actually, if you put infinity here, 1 upon n square, this will become 0, and then 0 n to the power 0, actually p is equal to 0, which is less than 1. So this is divergent from the p test actually. Okay, so remember this question. The entire thing is a bit messy, but all is the understanding. So if you are understanding it, great. Otherwise, I will take up another question. This is the question: assuming that limit n tends to limit n equal to n to the power 1 by n is equal to 1, show that the series this is convergent. So this question you will solve in your own. I am giving you hint, first of all, hint for hint purpose. Let's take u 1 u to the power 1 upon n is equal to n to the power 1 upon n minus 1. Limit n tends to infinity, u1 to the power, this will become 0. This is actually, I'm giving you hint, you solve this on your own. Okay, and let me know in the comment section that if you solved this properly or not. Okay, or do I need to solve it for you guys? What do you want? Just tell me. Okay, just solve it. Okay, I'm giving you hint that u to the power 1 upon n is equal to this, and then you have to solve this completely. Also, I'm telling you that this will going to be convergent. Okay, this will the answer will be 0 actually. Okay, now solve this. Okay, bye bye.